Hi, everybody. Welcome back. We are up to lesson 10 of Unit 2, and this is just going to be a continuation of what we learned about in a previous lesson. One of the characteristics of a polynomial that we haven't talked about is something called the multiplicity of an x-intercept. And what the multiplicity is simply the number of times an x-intercept of a polynomial occurs. The number of times an x-intercept of a polynomial occurs. And the way we find the multiplicity of an x-intercept is we look at the exponent of its corresponding factor. That exponent is the multiplicity. And the reason the multiplicity is significant is that if it's odd, the graph will cross to the other side of the x-axis. If the multiplicity of an x-intercept is even, it will still intersect the x-axis. It will still touch the x-axis, but it will not cross to the other side. So if it's an odd multiplicity, it will not only touch the x-axis, it will cross over to the other side. If it's an even multiplicity, it will touch the x-axis but stay on the same side overall that it was at. So with that in mind, let's go ahead and take a look at the examples for today. So for each of the following polynomials, find the leading term without actually using the box method. Find the leading coefficient. Find the y-intercept without actually using the box method. Find the degree. State the end behavior of the polynomial. Find the x-intercepts, and then determine the multiplicity of each of the x-intercepts. So this is kind of a summary of everything we've been learning about in the last few lessons. So the key is we're going to do all of this without actually looking at the graph. So find the leading term without actually using the box method. So the way we're going to do that, the first thing we're going to do is we're going to take the polynomial in factored form, and we're going to rewrite it in a different way. So I'm going to rewrite it as x plus 6, x plus 2, x plus 2. Notice I wrote x plus 2 twice. Why did I write x plus 2 twice? Because notice in the polynomial, in the original polynomial, it says x plus 2 squared. Okay? X plus 2 squared, what that means x plus 2 multiplied by itself. That is the very definition of squaring something. Squaring something means to take that thing, in this case x plus 2, and multiply it by itself. If it had said x plus 2 cubed, I would write x plus 2 3 times. If it said x plus 2 to the 4th, I would write x plus 2 4 times, so on and so forth. So I could actually do the same thing in number 2, because I have 2x plus 1 squared, which means I need to write that twice. 2x plus 1, 2x plus 1, and then x minus 2, and x minus 9. So that's the first thing I'm going to do. Now to find the leading term, what I'm going to do is I'm going to multiply the first term of each of the factors. So multiply the first terms of all factors. Okay? So in this case, in number 1's case, the first term is going to be x times x times x. So x times x times x. X times x times x is x cubed. That is the leading coefficient. In number 2, that's going to be 2x times 2x times x times x. So 2x times 2x times x times x. So if I multiply all that together, 2 times 2 is 4. And then I have x times x times x times x. So that's going to be 4x to the fourth. So the leading term for number 2 is 4x to the fourth. The leading coefficient is simply the coefficient of the leading term. So the coefficient of the leading term. So in the case of number 1, the leading term is x cubed. What is the coefficient of that term? The coefficient is 1. It's 1x cubed. So the leading coefficient is 1. For number 2, the leading term is 4x to the power of 4. The coefficient is 4, so the leading coefficient is also 4. Okay? So that's the leading coefficient. Find the y-intercept without actually using the box method. So remember, we've talked about this in a past lesson. To find the y-intercept, we actually look at the constant terms, the constant term of a polynomial. So to find the constant term, I'm going to multiply the constant term of each of the factors. So to find the y-intercept without actually using the box method, I'm going to multiply the constant term of all the factors together. So a constant term, remember, is the term that doesn't have an x. So in the case of number 1, my constant terms are going to be 6 and 2 and 2. So that's going to be 6 times 2 times 2. Multiply all of the constant terms together. So 6 times 2 is 12, times 2 is 24. So the y-intercept for number 1 is 24. For number 2, my constant terms are 1, 1, -2, and -9. So multiplying all those together, that's going to be 1 times 1 times -2 times -9. So 1 times 1 is 1, times -2 is -2, times -9 is going to be positive 18. Okay. The degree. The degree, that's easy. Remember, the degree is the largest exponent. The largest exponent is in the leading term. So if the leading term for number 1 is x cubed, then the degree is 3 because of the cubed. In number 2, the leading term is 4x to the power of 4. So 4 is the degree. So that's the degree. Next, state the end behavior of each of the polynomials. State the end behavior of each of the polynomials. So remember, to find the end behavior, let me show you. We have to use this graphic here. So we need to know the degree, and we need to know the leading coefficient. So for number 1, the degree was 3. So that is an odd degree. And the leading coefficient was 1, which is positive. So I have an odd degree and a positive leading coefficient. Odd degree, positive leading coefficient. If I put all that together, that's going to be down here. So my end behavior is down to the left and up to the right. So my end behavior for number 1 is down to the left and up to the right. Down to the left and up to the right. Okay? For number two, my degree was 4. So that is an even degree. So that's this one right here. All right. And my leading coefficient was also 4. So I have an even degree and a positive leading coefficient. Even degree, positive leading coefficient. So my end behavior is going to be this one right here. So that's going to be up to the left and up to the right. So my end behavior for number 2 is up to the left and up to the right. So up to the left and right. So that's my end behavior. X-intercepts, remember to find the x-intercepts, I have to set each factor equal to 0. Set each factor equal to 0 and solve for x. So in number 1, my factors are x plus 6, x plus 2, and x plus 2. All right, so if I set those equal to 0, we can use that switching signs trick that I've talked about before. If I set x plus 6 equal to 0, then that means x is going to be equal to negative 6. I'll have to subtract 6 from both sides, and I'll end up with 0 minus 6. If I take x plus 2 and set that equal to 0, I'm going to do the same thing, except I'm going to end up with x equals not negative 6. I'm going to end up with x equals negative 2. And if I were to do that, the same thing with the third factor, I would just get x equals negative 2 for a second time. So negative 2 would occur twice. Still means there's only 2 x-intercepts for this particular one. For number 2, same thing happens. So I have 2x plus 1, 2x plus 1, x minus 2, and x minus 9. And if I do the same thing, so if I do 2x plus 1 and set that equal to 0, I'm going to end up with 2x equals negative 1 if I use that switching sign trick. But because of the 2x, I'm going to have to divide both sides by 2, and I'm going to end up with x equals negative 1 divided by 2. So that's going to be negative a half. So x equals negative 1/2 is my first x-intercept. And I'm actually going to get that twice, right? X equals negative 1/2 twice because of the 2x plus 1 occurring twice. Then if I take x minus 2 and set that equal to 0, I'm going to end up with x equals positive 2 for my second x-intercept. And the last x-intercept I'm going to have to do over here because I'm running out of room. But if I take x minus 9 and set that equal to 0, I'm going to get x equals positive 9. So there are 3 x-intercepts. X equals negative 1/2, x equals 2, and x equals 9. So that's the x-intercepts. Last part, determine the multiplicity of each of the x-intercepts. So to find the multiplicity, we're going to go back and look at our lesson notes. The multiplicity, as it says here, is the exponent of the corresponding factor. The exponent of the corresponding factor. So on number 1, we had 2 x-intercepts. We had an x-intercept of negative 6 and an x-intercept of -2. Now, x equals -6. If I look at its corresponding factor, x plus 6 had an exponent of 1. It was x plus 6 to the power of 1. So -6 has a multiplicity of 1. -2, on the other hand, is going to have a multiplicity of 2 because its corresponding factor, x plus 2, has an exponent of 2, x plus 2 squared. So -6 has a multiplicity of 1, and -2 has a multiplicity of 2. For number 2, there are 3 x-intercepts. There's 9, there's -1/2, and there's 2. So for 9, its corresponding factor was x minus 9, which has an exponent of 1. So multiplicity for 9 is 1. The multiplicity for -1/2 is going to be 2 because its corresponding factor, 2x plus 1, has an exponent of 2. And then lastly, 2 is going to have a multiplicity of 1 because its corresponding factor, x minus 2, has an exponent of 1. So these are my multiplicities for each of the x-intercepts. And that is it for this lesson.